Okay, this is lesson 1.3 over midpoint and distance formula and also bisectors. So we start out with distance formula, which is at the bottom here. So anytime you're looking for the distance between 2 points, you should have 2 coordinate points. What you'll do is subtract your x's and then square them, and then add that to the difference in your y's, which is also squared. So we can call this point x1, y1, and this one x2, y2. So we get negative 3 minus 3 and negative 1 minus 2. So negative 3 minus 3 is really negative 6. And negative 1 minus 2 is really negative 3. Now be careful when you square those. If you don't put parentheses around them in your calculator and you do them in your calculator, you won't get the right answer because it will make it negative. Negative 6 times negative 6 is a positive 36. And negative 3 squared is a positive 9. Now you end up with the square root of 45. And it says to leave it as a simplified radical, so now we just have to simplify it. So square root of 45 will break down to 9 times 5, and this will break down to 3 times 3. And so you can bring out a pair of 3's, and you have a leftover 5. So your distance is 3 radical 5. Now distance is just Pythagorean theorem. So if you don't want to write out this whole formula, you could plot the points on a graph, and there's always graph paper available in the room, and then count over 1, 2, 3, 4, 5, 6, and then up 1, 2, 3. And then you could just do Pythagorean theorem, which would be 3 squared plus 6 squared equals whatever that side is squared. And you'd end up with the same thing here because we did 6 squared and 3 squared, and then at the end you take the square root. So you can always do it that way. Now I'm going to show you a shortcut for how I would do it. I just think of a number line in my head. So on a number line, how far apart are a 4 and a 2? They're 6 apart. That's the same thing as subtracting. And then I remember to square it in my head so that the first step I write down is really the third step here. So they are 6 apart. I square it and get 36. And then 5 and negative 1 are also 6 apart. Square it, I get 36. Then we have radical 72. You can break that down into 36 times 2. That I'd break down to 6 and 6, and then I'd just bring out that pair right there. You don't have to keep going. So you get 6 radical 2. So you can do it either way. And that would be what it would look like if you wanted to do a graph. I have all the graphs in here, but I don't generally do them on a graph, especially distance formula, because I like thinking through it. So I would just pause this and try this problem, and then you can unpause it and check with what I got. Okay, so 6 and negative 3 are 9 apart. I square it, I get 81. 5 and 4 are 9 apart. Square it, I get 81. Okay, so then I get, sorry, that's a little messy. 81 and 81 is 162. I'd break it down to 81 and 2, and then 9 and 9. And you should have gotten 9 radical 2. Now, if you want, you can type this whole thing in your calculator. Just don't type the radical, because then it will take the square root of 162 and get a decimal, which I think is about 12.7. And that's not going to be right on these simplified radical problems. But you could do it without the radical, get the 162, and then break that down if you want. All right, next we have midpoint formula, which is just the point in the middle. So basically what you do is you average your x's and you average your y's. So if these are my two endpoints, I'm going to add my x's together, divide by 2, add my y's together, divide by 2. Now make sure if you put these in the calculator, you have to put the top in parentheses, or you could do the alpha y equals enter to get the big fraction bar. But I would just add them separately, like add -8 and -2, get -10, and then divide in a different step. So 10 divided by 2 is going to be 5 and -5. Always, always, always put parentheses around a coordinate point. So that point is halfway in the middle between these 2 points. So pause it and try these 2 examples. Midpoint formula is pretty straightforward. You just add them together, divide by 2, add them together, divide by 2. So see if you can get those. Now some of you may have had teachers that said don't put 2 signs together like this. I think it's easier to just plug it in exactly like it looks in the formula. So I'm okay with you doing that. If you don't want to do that though and you want to just put a minus sign there, that's fine too. So on this one you get 3/2 and then 0/2. You can leave it as a fraction or you could put the decimal. Just make sure it's simplified. Like don't leave that as 0/2, but you could leave it as 3/2 since that's a reduced fraction. So this is 6/2, 6/2, and you get 3, 3. Alright, then we have these kind, which this gives you one endpoint and the midpoint, and you have to find the other one. Now this could be pretty tricky, but I've found the best way that I think to do it, and I'm going to show you that way. Actually, let me write that up here. So we have R and T, and S is the midpoint. And it gives us that R is -6, -1, and S is -1, 1, and we don't know T. So the easiest way for me to do this is to just think how far apart are 6 and -1. So to get from -6 to -1, I have to add 5. And that's halfway to this x. So to get to that x, I'd have to add another 5 to this -1, and I would get 4. Then from -1 to +1, I've added 2. So to get to this other y, I would have to add 2 to 1, and I'd get 3. So this is our other endpoint. So I'm going to show you another one. I like to write them vertically. It makes more sense when you see the picture to do it horizontally, but it's easy to write this way, and then it's clearer. You don't have all your lines crossing each other. Okay, so from 1 to 9, I add 8. So from 9 to here, I'm going to add 8, and 8 plus 9 is 17. Then from -7 to +3, I've added 10. So from 3 to here, I would add another 10, and I would get 13. So take a second, pause it, see if you can do this next one all on your own. Alright, so from here to here I add 4, so 6 plus 4 gets you 10. From here to here I actually subtract 6, so I'm going to subtract 6 from 1 and get -5. Alright, so definition of a midpoint. So we did midpoint formula, and this is just going to be if we're not given coordinate points, we're given like lengths of segments. So we have a midpoint right in the middle of the segment, and all midpoint says is that it makes this half equal this half. So it would look something like this in a proof. Now, anytime you'd write this in a proof, definition of a midpoint, that's what I underlined here, that would be what you would write down for your first reason. Definition of a bisector, same thing, you'd write this definition of a bisector. Bisect means cuts in half. I'll ask that a lot. I'll say, what does bisect mean? And hopefully you can say cuts in half. So it can cut a line segment in half or an angle. We'll do this next week when we deal with angles, but it would look very similar to midpoint. Okay. So on the next two slides, it's the same problem, but just solving it regularly, and then we'll solve it with a proof. So on this one, it says that M is the midpoint of Ln, which means that it cuts these two into two equal halves. So x plus 9 should be the exact same as 4x. And then you just have to solve that. So I would subtract the x from both sides. You get 9 equals 3x. And then divide by 3. And you get 3 for x. But of course, it's not asking for that. It's asking to find Ln. So let's see. Ln is the whole thing. So if x is 3, then 3 plus 9 makes 12. Same with this. 3 times 4 makes 12. I know you don't have to check both of them, but I would just to make sure you solved it right. So Ln, the whole thing, is 24. And I'm sure the proof wants us to find that same thing. So it says prove that Ln is 24. So remember, when you're doing a proof, the first step is not going to have numbers. So it says it's the midpoint. So let's go to definition of a midpoint. And remember, it's going to look something like this. So you're just saying each half is equal to each other. And whatever's underlined is what you write as your reason. So on this one, it's not AM, it's LM, and it's not MB, it's MN. But we know that the two halves are equal. And that's going to be definition of a midpoint. And you can write def of midpoint. It's good handwriting. All right, the second step is always substitution. So plug in x plus 9 and 4x. Then we subtract the x, but now we don't show it. Now over here I showed my work, but remember, you don't show your work like that in a proof. So you just write what you have next. So we get this after we subtract the x from both sides. So that is subtraction. And then we divide both sides by 3 and get division. Now we're proving Ln, so we got to plug it back in. So remember, you have to have you can't do Ln equals because it's the whole thing. So this is actually a trickier one. This is like the more tricky type of proof because it actually has two big geometry statements. You can't just put that Ln equals these added together because that is not given to you. But there is something we've done that lets you add them together to equal the whole thing. And that is segment addition postulate. So then we substitute in x plus 9 plus 4x equals Ln. Now you can combine like terms if you want, but you actually don't have to. You can go ahead and plug in these. Sorry, I just realized I wrote substitute. I meant try substitution. Now, I've told you before that if the reason is the same, you can do it all in one step. However, that's not true if you do substitution and then substitution again, because at one point we're substituting these expressions, and on the other one we're actually putting in a number. So on this one you can do 3 plus 9 plus 4 times 3 equals Ln, and that's substitution again. Then you actually solve that and hopefully you get 24. And because we just did math on one side, that's arithmetic. And then you got to flip it around, and that's symmetric property. And like I said, that's a more difficult proof because it's got two big geometry statements in it. So then we have the bisector, which is essentially the same thing. If it bisects, then it goes through the midpoint, so it still just cuts it in half. So x plus 20 equals 5x minus 4. Subtract x, and you get 4x minus 4. Add 4, you get 24 equals 4x, and then x equals 6. And that's all it wanted us to find. Hopefully the proof is the same way. It is. Okay, so notice on the, or if we solve it this way, you end up with 6 on this side. So you'd have to do that extra step where you do symmetric property and you flip it, which isn't a big deal. But when we're on this side, if we know that's going to happen, we can make it to where we get the x on the right side by saying MB equals AM. It's still setting those two equal. So you can do it like that, and then the x will end up on the correct side, and it saves you a step. But not that important. You don't have to do that. So this one is just definition of a bisector. Now, they look very similar. The only difference is that this one actually says it bisects. The other one says midpoint. That's a big clue as to what your first reason is going to be. So then we substitute MB is 5x minus 4. AM is x plus 20. Then we subtract the x, and then we'll add the 4. So since it's two different things, we have to do it in two different steps. So we get 4x minus 4 equals 20. That was subtraction. Then we add the 4 and get 4x equals 24. That's addition. Then we divide and get x equals 6, and that is division. And then we're finished because we have this right here. All right, and that's it.